In this chapter, we're going to be talking about bond yield. First, we're going to define what the yield to maturity is. This is in Spanish, la tasa de rendimiento al vencimiento. And we're going to see two very important things. First, that the yield to maturity is neither a good estimate of realized return, and the second thing is not a good way to determine whether bonds are overvalued or undervalued. And finally, we're going to see how yields and coupon bonds relate to zero coupon yield curve. This chapter is really important because basically what we're going to do is I'm going to take all your preconceived ideas and all the knowledge that you previously have for bonds and the yield to maturity, la tasa de rendimiento al vencimiento, and I'm going to pretty much say, look, all you learned there, it was really useful, but there are some problems with that way of thinking. Okay, so by the end of this chapter, once I show the two problems that there are with the yield to maturity, then I hope you're convinced of what I'm saying. So what's the definition of yield to maturity? Tasa de rendimiento al vencimiento. The yield to maturity is basically a discount rate that you use. So in this case, this is going to be our Y here. That allows us to discount all the cash flows that a bond has, so K1 up to KT, to get the bond price. So it's very important here to notice that this yield to maturity is the same for all the cash flow. So it doesn't change. Like before in discount factors, we had one discount factor for the first cash flow, another discount factor for the second, and so on. Here, no, I'm going to have exactly the same rate, the same yield for all the cash. Now, KT is going to be the cash flow period, and Y is going to be the yield to maturity, or in Spanish, tasa de rendimiento al vencimiento. And the other technical difficulty is that when you have a portfolio of bonds and you want to find, okay, what's the yield to maturity of my portfolio, there's not an easy way of doing that. So it's not like, oh, you know what, let's take the average of the yields of the bonds and we're going to get my yield to maturity for the portfolio. No, there's no way of doing that. You would have to take all the cash flows of all your portfolio and then compute the yield to maturity for your portfolio. Yeah. So this is an example from the Martellini's book. So in here we have a bond. So this bond has a par value of 1,000, pays 10% coupons, and it sells for 101. So in here I'm going to put this in thousands. So this would be the price. These are going to be the two coupons, and here the par value throws a coupon. And the whole idea is, okay, how do I solve for Y? So there's going to be one Y that we solve by trial and error, and then we're going to get that the Y to solve for this is the 9.601%. Another way to solve this is with a financial calculator. You can also solve this problem in Excel, and then you have to put also the number of periods and use this formula rate, and the formula rate where you put the number of periods, the coupon, the par, and the price, it's going to return you the yield to maturity. There are some really interesting facts about the yield to maturity, the coupon rate, and the price. So in this case, we have three cases. So the first one is when the yield to maturity is equal to the coupon. So normally when you issue a bond, so a new issue, what's going to happen is that the yield is going to be equal to the coupon rate. And then in this case, the price of the bond is going to be equal to the par value, so it's going to be equal to 100. So let's imagine that you own a company, and then this company issues a bond, and at issue the yield to maturity is equal to the coupon, hence the price is equal to 100. Now this company does really well, and then the price of this bond goes up, say, to 120. So you're really happy, and then you ask yourself, okay, what happened with the yield? So the yield now should go down, so it should be less than it originally was. So if at the beginning, let's say the coupon was 5%, and that was also the yield, 5%. So now the yield is going to be way lower than this 5%. It's going to be, say, 2%. So then in this case, when the yield is lower than the coupon rate, so here the price is greater than the par value. So in this case, the 120, the new price is greater than 100. And we say that the bond is selling at a premium. So this is a good. Conversely, price goes down, so the company now is doing really bad. So the price now is, let's say, at 80, hence the yield went up, say, to 8%. And then in this case, so the yield is going to be higher than the coupon. The price is now going to be lower than par, and we say that the bond is selling at a decent. In this case, one of the things that you have to think about, say, when it goes down to 8%, is, let's say, the company wants to refinance themselves. So before they were paying a coupon of 5%, so now in this new scenario, if they want to issue new bonds, coupon would have to be 8%. So it's going to become more expensive. So in a way, this company is at higher risk. That's why you have to pay the extra coupon. And here we're going to talk about the yield to maturity and realized return. So even though we can hold a bond until maturity, the return on a bond is going to depend on its reinvestment rate for the coupon. In the cases before, we always assume that, let's say this bond, that bond A, is a 10-year bond with annual coupons. It pays a coupon of 8, it has a price of 100, and the yield to maturity is 8%. Now, in this bond, the 8% means that we assume that the coupons are going to be reinvested at this rate. What do I mean by that? So what I mean by that is that, like, if you have your 10-year bond, so this goes like your first coupon is going to be received here, and it's going to be a coupon of 8. Then the question is, once you receive that coupon, what are you going to do with it? So if you put it under your bed, you're going to get 0% on it. Then if you decide, okay, I'm going to reinvest that coupon, all right, how much are you going to reinvest it at? Now, in the computation of the yield to maturity, this coupon is assumed to be reinvested at the yield to maturity. So that's a very strong assumption. So what we're going to see is this case where we have 3 bonds, A, B, and C. One pays a coupon of 8, 6, and 4. These are the prices and these are the yields. And the whole question here is whether A is a better investment. And the answer is going to be not necessarily. So let's see an example of what could happen. So here we're going to compute the annualized total return after 10 years of our bond. So in here we have our 3 bonds, the 8%, the 6%, and the 4%. And we're going to work with different reinvestment rates, 4%, 8%, and 12%. So what do I mean by that? So the point here is, if the reinvestment rate is 4%, then you see that the bond that is going to get the highest return is bond C. So this should be surprising, right? You're like, what the hell? Like, why would I go and buy this bond and think that this bond, like, no matter what, is going to do better? Well, it's not the case. It depends on the reinvestment rate. So for example, if right now the interest rates are going down, then it might not be such a good idea to buy the bond with the highest coupon. Why? Well, because you're going to be able to reinvest that bond at very high rates since they're going down. Now, in the case where the rates are 8%, then the best bond is going to be the one with 8%, as is the case with 12%. So in general, like, what's going to be the rule? The rule is going to be that if the reinvestment rate is, you expect it to be lower than the coupon, the bond with the lowest coupon might be a better return. The next thing we're going to do is we're going to talk about synthetic replication. So we're going to take this 3 bonds and then we're going to try to understand, well, how are they related one to the other. So in the first case, we're going to take bond A and C to replicate bond B. And then we're going to find what the synthetic value of that is. And next, we're going to do the same thing. We're going to replicate C using B and A. So this is going to be a really interesting exercise. If you already know how to replicate B using A and C, please go ahead, like, stop the video and do it yourself. Otherwise, look at what I'm going to do to use A and C to replicate B, and then do the same thing for C. So the goal here is to replicate B using A and C. So all the cash flows are A, B, and C. So it pays a coupon of 8, 6, and 4. And then the prices are 100, 87.6, and 74.5. And these bonds look like from 1 up to year 10, they pay the par value of 100. So here the coupon is, say for bond A, it's going to be 8. Now for the replication. So for the replication, we need 2 equations, 2 unknowns. So the first one, I'm going to work with the coupon. So the coupon equation is going to be the $6 of B, since that's the one I want to replicate. So it's going to be 8, and how many units I need of A, plus 4, and how many units I need of C. So this is using A and C to replicate B. And then I'm going to do the same thing for face value plus the coupon. This is going to be 106 equal to 108 and A plus 104 and C. What do I find? I find that NA is equal to 0.5 and NC is equal to 0.5. So basically, if I buy half of bond A and half of bond C, I'm going to obtain bond. Next question I'm going to ask is, what's the price of B, but the price of the synthetic? So what's the synthetic? Synthetic price is the one that I get if I buy these two, NA and NC, if I buy half of them. So this is going to be NA times the price of A plus NC times the price of C. This is going to give me the price of B, but the synthetic one, since we already have the one in the market. So the one in the market is the 87.6. So this would be 0.5 times the 100 plus 0.5 times the price of C, which is 74.2. And I obtain a price of 87.2. And this price is lower, so the synthetic price is actually lower than the market price, 87.6, which is price in the market for B. Now, if you do exactly the same thing for C, so you go and replicate C using A and B, then you're going to find that the price of the synthetic C, you're going to need to buy, or to sell actually, 1 unit of A, and you're going to need to buy 2 units of B. And the price you're going to obtain is 75.2. That's the price of the synthetic. And then you compare that price with the market price, and the market price 74.4. So this price is actually higher than the one of the synthetic of 74.4. This is the price in the market for C. Now, if you go back and look at the slides, you're going to find that B, but B has a higher yield to maturity than C. So it's like, what the hell? So if you went and bought B because it had a higher yield to maturity, you would make a mistake. Why? Because this bond here, bond B, is actually overvalued by the market. So this bond is overvalued. How so? Well, you found that there's a cheaper way of getting exactly the same cash flow by combining bond A and bond C. So if I ask you, okay, which one are you going to buy? The one in the market or the synthetic? You say, no, the synthetic, it's cheaper, right? Now, this bond C is actually underpriced in the market. So if I ask you, okay, which one are you going to buy? The synthetic or the one in the market? You say, no, the one in the market is actually cheaper. So if you had to go and trade the securities, which one would you trade? Well, you would say, okay, I'm going to buy this one, and then I'm going to sell the synthetic, or I'm going to buy the synthetic in this case, and instead of the market price. So the whole point here is that B, which is overvalued, has a higher yield than C that is undervalued. So the big conclusion here is that the yield to maturity does not tell you if a bond is under or overpriced. Now, you ask yourself, okay, so what do I use the yield to maturity for? Well, the yield to maturity is basically used to recover the price of a bond. That's it. That's the only usage you have. So in isolation, you can use it. You can talk about your bond and say, well, it's like the price of this bond is $100 or $105, and the yield to maturity is this much. But you cannot go and compare two bonds using the yield to maturity. You cannot go and say, oh, this bond is better because the yield to maturity is 10 and the other one is 5. There's no way of doing that. To be able to compare two bonds, you have to go and do this synthetic replication, or you have to do some kind of term structure, yield curve, discount factors to be able to find which bonds are cheap or underpriced and which bonds are rich or overvalued. That's the only way of doing it, not by using the yield to maturity. So what do we conclude in this chapter? That the yield to maturity is not a good way to compare bonds. And the second thing we find is that there's a negative relation between the bond price and the yield to maturity.